The goal in this section is to take polynomial inequalities, so therefore we're going to use the methods of solving polynomials in Chapter 2 and apply it to inequalities. Let's take a real basic one first. So number 1, x to the fourth minus 4x squared is greater than or equal to 0. First we got to see what the graph looks like. So we can factor this one. Pull out an x squared, we're left with x squared minus 4. We can then factor the x squared minus 4 into x plus 2, x minus 2. And you can see that we have x-intercepts at 0, which is a double root, and plus or minus 2. We can then complete our sign analysis. 0, 2, negative 2. Now we've got to be careful. This here tells us what kind of mark to make on those. Since this problem, it can be equal to 0, I'm going to put closed dots on all of these values. Now, I can do my sign analysis. If I plug in 3, it's positive. If I plug in 1, it is negative. If I plug in negative 1, it's going to be positive. And if I plug in negative 2, it's going to be, I'm sorry, this one's negative, and then positive. Therefore, you just have the answer in front of you. When is it greater than or equal to 0? When it is positive. So this region here, this region here. We just have to write that. So x must be less than or equal to negative 2, or x must be greater than or equal to 2. I'm going to share with you some new notation for this. This answer would be fine, except I made one mistake. These both are right, but check out this closed dot there at 0. Don't forget to put x equals 0. I often forget it, except on a test or a quiz when I'm actually being careful. Just make sure that you are careful in adding those extra points. I'm going to use a different notation now called set notation. And what we do is, you use a parentheses to represent not equal to, and brackets for equal to. And what is it? It is an interval. So for example, this first interval over here is from negative infinity to negative 2. So I'm going to write it as negative infinity to negative 2. You can never be equal to negative infinity. This side is equal to because of the closed dot. This one would then be equal to 2 to positive infinity. And then obviously x equals 0. Again, I don't care how you write it, but I do believe by the end of the year you will grow more accustomed to my method. Let's do another problem. Number 2. 2x squared plus 3x minus 5 is less than 0. So our goal now is just to factor it. So we can apply the methods from PST. And we get 2x plus 5 and x minus 1. So x can be equal to negative 5 halves or 1. So now we go to our number line. Be careful. We have to apply our dots. This here is not equal to 0. Therefore, these must be open dots. At these values, it is equal to 0, not equal to 0. Therefore, let's now plug in our values. Let's plug in 2. 2 would give us positive. Since it's a parabola, you know it has to be negative than positive. And therefore, since it's less than 0, it must be this answer in between when it's negative. So the answer is negative 5 halves to 1. Notice again, parentheses, because it is not equal to. And that concludes this short mini lesson on polynomial inequalities. In class, we will go further with this by applying synthetic division. Have a good night.